Hello guys, this is Ramanujan and welcome to my channel. In today's video, we're going to discuss about the man who knew infinity. The man who had whole numbers as his secret friends. Yeah, this is what Littlewood talked about him. This man who changed entire mathematics. Srinivasa Ramanujan, whose birthday is celebrated as National Mathematics Day today. So he was born on 22nd December 1887. So, let us begin with telling about some facts about Ramanujan, and then we'll talk about the contributions he gave. Okay, so Ramanujan was born on 22nd December 1887 in Madras Presidency, Erode. Okay, and then there he had his deeply interest for mathematics and not for any other subjects. He failed all the other subjects and he was doing good in mathematics. He used to read a book that time, which is not read, solve, okay, at 15, which is synopsis of elementary results of pure mathematics, which is by George Carr. It's a high level book, okay, about all the formulas and theories, more than 5,000 formulas and theories. And then he used to solve it at 15 without proofs. He just writes the results, not the proof itself. This is completely extraordinary for a person at that age. Okay, so he then used to write formulas in his was Namagiri temple stores. And then he used to make theories and send it to mathematicians like GHRD. GHRD invited him to University of Cambridge, and his mother was scared he might lose his religion. At that time there was a superstition, but the goddess Namagiri came in her dreams and told her to send her child to Cambridge. Then he went to Cambridge, and there with Littlewood and Hardy he made wonderful contributions. One of the famous incidents you must have heard is the taxi cab number 1729, when Ramanujan was sick in his late years. That time Hardy was coming to hospital. There he said, I saw a number in the taxi cab, the plate number, and then it was boring. It is 1729. Ramanujan said, no, it's not. It's nothing but it's the smallest number to represent it as sum of two cubes, 12 cube and 1 cube, 10 cube and 9 cube. Okay, so this is a story you must know, but let us talk about some advanced contributions here. Number one is pi. Sorry, not pi. Infinite series. So he said, okay, first of all, let me just show you. This is what Grandi did, okay? Grandi series. Okay, which is nothing but 1 by 2, okay? I am not deriving it right now. And then there is one more series. This, which is nothing but 1 by 4. So, using this equations, okay, he found out a new expression, okay. He found out that 1 plus 2 plus 3 plus 4 plus dot is equals to 1 by 12 minus. What a wonderful, fact he gave about the summation series, infinite series. He said the sum of 1 plus 2 plus 3 plus 4 plus 5 plus 6, whatever going on, is minus 1 by 12. So he derived it using these two numbers. If you want to do it, you can do it. I'll tell you basics, that subtract this from this, just keep this as side, subtract this from this, and then you get 4 plus 8 plus 12, and then you get, that is nothing but 3 of this. So 3z is equals to z minus 1 by 4. So 3z is equal to minus 1 by 4, so z is equal to minus 1 by 12. This is how you can derive this expression. And this is how Ramanujan derived this expression too. Second is the partition function, okay? So, partition function is nothing but how many number of ways you can break a number. Okay? So, for example, if you have partition of 4, it's only 1 plus 1 plus 1 plus 1, or 4, or 2 plus 2, or 2 plus 1 plus 1, or 3 plus 1. Only 5 ways, like that. So he found out a formula that partition of any number is nothing but 1 by this exponential by 2n by 3. Okay, exponential means e to the power this stuff. N is a number of terms. First term, second term, like number you have to break. Okay, not number of terms. Sorry, number you have to break. So if you have to break 1, put 1 in the formula and you get the answer, etc. E's value, if you don't know, it's 2.718 ... and pi is 3.159. So with this formula, he calculated the partition of every single number because it gets extremely huge as you go to 50s and 100. 50s it leads to 100,000 or maybe a million, and then he same with hundreds. It reaches million. 200 it reaches 100 million. This is how big it gets. That is why to solve it you need such expressions. Third he did was formula of pi. So if you are familiar with the Euler's expression, pi squared by 6 is equals to summation of 1 by n squared, n is equals to 1 to infinity. Now, which means that 1 plus 1 by 4 plus 1 by 9 plus ... is equals to pi squared by 6. So if you take one term, 1 is equals to pi squared by 6. So pi is equals to root 6. Here, pi squared is equals to 6 by 4. 3 by 2. So pi is equals to root 3 by 2. And then if you take, sorry, not 3 by 2. So we take the entire thing. So it's 5 by 4 and then 30 by 4. And then root of 30 is approximately 5 and root of 4 is approximately 2. So yeah, approximately it gets to pi as fast as you go. Far you go. But it is not as fast, okay? It converges slowly. So, if you see Ramanujan's function, he gave is 1 by pi is equals to 2 root 2 9801. Okay? Summation from k is equals to 0 to infinity, and then we have 4k factorial into 1103 plus 2 . Okay. Now this is the formula he gave, and then after solving it you get the value of pi as approximately 3.14159 and 270 if I'm not wrong. 2730 ... So here it is correct and then it starts diverging, but yeah, for 0th term, this is for k is equals to 0. It's great for the 0th term to be like this. And the last contribution he gave was mock theta function. So before that, let us know what is theta function in brief. So a theta function is from a real number, imaginary number to a real number is equals to Now here it is periodic for this imaginary number. Okay, this is Z. So it is periodic for this imaginary number. Second, it is satisfying the heat equation, and third, it helps us to find the square of sum of squares and lattices. Okay, so this is the theta function. According to Ramanujan, he invented a mock theta function, which is summation of 0 to infinity. If you know, yes, a where mod of q is less than 1. Now, if you see, if we give one more equation where qn square divided by 1 plus q square, 1 plus q square square, and so on. So, this formula he derived in his late years, okay? So, late years, he derived it in his 1920s. Because he died in 26 April 1920s. So this function here is the mock theta function, because mock theta means mock. It is like theta function, but it is not a theta function. So, as you know, an entropy, which is nothing but number of chaotic stuff, unorderedness, is the log of number of microstates, quantum microstates. Now, for a black hole, okay. So this formula came to be similar when you expand it to Mach theta function. So that is where Ramanujan's formula helped us to understand black holes in a better way. So this is about Ramanujan. I wish you again a happy National Mathematics Day, and then keep learning. Thank you. Stay safe. Bye bye.